Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on October 22nd, 2025, just yesterday. The big punchline is that world model-generated data lets robots learn far more broadly, with real robot success jumping by about 30% on laundry folding and about 10% on paper towel prep and mobile tasks. The paper is titled GigaBrain-0, a world model-powered vision language action model. And as we'll see later, the implications for training efficiency are quite significant. Beyond the gains, the model uses RGBD perception and embodied chain-of-thought, plus a small version that runs on Jetson AGX Orin. Also, the authors shared the code on GitHub. You'll find an initial open-source repo with the core project folder, a README, and an Apache 2.0 license. There are no releases or packages yet. It looks early and minimal, but the implementation is accessible and likely to evolve. Alright, Figure 1 presents the core idea. The model learns from a blend of real robot experience and world model-generated data, so it can generalize across tasks. World model-generated data means synthetic videos and trajectories produced by generative models that simulate new robot experiences. The panels illustrate 5 key sources, including video generation, reel-to-reel transfer, human transfer, view transfer, and sim-to-reel transfer. The funnel layout conveys that all streams feed one unified policy. So, while Figure 1 framed the data sources, Figure 2 shows how the policy is built to use them. The top row depicts embodied chain-of-thought, which means the model emits brief reasoning tokens like subgoals and 10 trajectory keypoints to guide control. The center band splits computation into a vision language expert and an action expert, which communicate through self-attention so semantics and control stay coordinated. Knowledge insulation blocks harmful crosstalk during training. The bottom row illustrates RGBD tokens and discrete action tokens flowing into the action expert for denoising. So, Figure 2 laid out the architecture. Table 1 contrasts how different systems source training data. The key message is coverage. This table shows that GigaBrain-0 draws from every listed stream, including public and self-collected data, egocentric human recordings, video generation, sim-to-reel, reel-to-reel, and view transfer. That breadth matters, because diverse scenes and viewpoints expose the policy to varied appearances and layouts, which strengthens generalization. So Table 1 laid out where the training data comes from. Figure 10 compares success rates across 6 real robot tasks. The bars show that GigaBrain-0 consistently outperforms the baseline Pi0, which indicates stronger generalization. On laundry folding, the margin reaches about 30%. Paper towel preparation shows a smaller but steady edge of roughly 10%. The mobile manipulation tasks also gain around 10%, so the unified policy holds up during navigation and interaction. So, Figure 17 shows that increasing world model data consistently lifts success under appearance, placement, and viewpoint shifts. The left panel climbs to over 80% at high sampling. The middle panel reaches around 90%, indicating strong robustness to where items are placed. The right panel crosses roughly 80%, showing resilience to camera viewpoint changes. These trends follow the sampling probability alpha, which signals that synthetic diversity directly improves real robot reliability. Wrapping up, 2 takeaways stand out. World model-generated data, meaning synthetic videos and transfers, dramatically boosts real robot generalization, while RGBD perception plus embodied chain-of-thought strengthens long-horizon spatial reasoning. The broader implication is scalable on device robotics, thanks to the compact Jetson-ready variant. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.